Hello students, last class we studied about what are polymers and what are the classification of polymers, how these are classified. Now let us today study about some examples of some polymers. Okay, so first let us consider some addition polymer. So addition polymer simply formed by some addition reaction. So first example is polythene. So this polythene two types, low density polythene and high density polythene. So this low density polythene are formed by polymerization of ethylene. This is also from polymerization of ethylene. But here temperature where pressure is high and here pressure is low. This is only the difference. Temperature almost same and here oxygen is used as catalyst, but here Ziegler-Natta catalyst is used. Okay, so polythene, one low density polythene. The monomer is ethylene CH2 double bond CH2, n number of last number of this, it undergo polymerization in presence of so temperature about 350 to 360 Kelvin and 1000 to 2000 atmospheric pressure, little oxygen, traces of oxygen or peroxide. If this, then it gives you CH2 and this is polythene. Ethylene or ethene. So ethylene when undergo polymerization, it forms polythene. And this polythene has generally more branchings. That's why these have low density polythenes. Okay, these are not closely packed, low density polythene. Next, high density polythene. So high density polythene is also formed from ethylene. High density polythene. This is also formed from this, but the temperature is slightly low, almost same, slightly low. This is about 333 to 350 within Kelvin and pressure is 6 to 7 atmospheric pressure. And here the catalyst used is generally used is triethyl aluminum in presence of titanium tetrachloride. This is called Ziegler-Natta catalyst. So this gives polythene. This is high density polythene. And these polythenes are generally used for manufacture of different containers, which can be used for storing chemicals, and these are used for preparation of manufacture of different households equipments like bottles, buckets, dustbins, etc. Okay. Next come to another type of addition polymer, that is polypropylene. So this here the monomer is propene. This propene is the monomer and it undergo polymerization it undergo polymerization, n number of these forms CH. This bond just breaks and you one side bond and another side this type of linkage CH, CH3, CH2 and this side. So this contains n number of polypropyl. Okay, so this is polypropylene. It is used for making seat covers, carpets, etc. for making toys and bottles. Okay, so this is polypropylene. Next come to another addition polymer. These are addition polymer, also known as your homopolymers, because only one type of monomer is used. Next come to another, that is polystyrene. Or we can say polystyrene. So here the monomer unit is styrene. This is styrene and this is polystyrene. This is polystyrene, and polystyrene is also used for making different toys, combs and drinking cups. So these are also used in the manufacture of lining of different different equipments, electrical equipments like TV, refrigerators, etc. So these are your polystyrenes. Next come to another type of addition polymer, that is polyvinyl chloride. Polyvinyl chloride, and vinyl chloride is also a polymer of so here the monomer unit is, we can write CH2 double bond CH. This is vinyl chloride. N number of this vinyl chloride undergo polymerization. This is vinyl chloride. So it undergo polymerization to form polyvinyl chloride. There is without elimination of any other small molecules. This is also addition polymer as well as a copolymer. This is polyvinyl chloride. So polyvinyl chloride is used for making the PVC pipes and polyvinyl chloride pipes, etc. Next, come to study about some other addition polymers, that is polyvinyl chloride. So polyvinyl chloride, the monomer is vinyl chloride, CH2 double bond CHCl. This is vinyl chloride. It undergo polymerization to form and this is polyvinyl chloride. So polyvinyl chloride is generally used in the manufacture of PVC pipes, for insulating electric installations, for insulation or electric installation. This is also used for making raincoats, tablecloth, handbag, gramophone records, etc. Okay. Next come to another type of addition polymer, that is polyacrylonitrile. Polyacrylonitrile, in short known as PAN. So this is acrylonitrile. Acrylonitrile, or we can say vinyl cyanide. Vinyl cyanide. And this is polyacrylonitrile. So this is also a homopolymer. This is addition polymer as well as a homopolymer, and it has fibrous-like structure. So due to its fibrous-like structure, it is used in the manufacture of synthetic carpets, blankets and sweaters, etc. So these are also known as orlon. This is a substitute of wool. Okay, polyacrylonitrile. Next come to, this is also homopolymer. Next come to another type of some addition polymer that are also known as rubbers. Now let us study some other addition polymer. So these addition polymer are also known as rubbers. These addition polymers also known as rubbers. So this may be homopolymer, this may be copolymer, but here the addition polymer, first let us discuss the natural rubber. Natural rubber is known as polyisoprene. So isoprene is so 2-methyl buta 1,3-diene, also known as isoprene. And this isoprene forms polyisoprene. So this bond comes here, this bond comes here. In this it forms CH2, CH3, double bond CH2. This is polyisoprene or natural rubber. But these do not satisfy the industrial purpose or the modern demand. In this it require for preparation of some synthetic rubber. There are some substituents of this. So these are known as your synthetic rubber. But natural rubber, this is a polyisoprene, this is a homopolymer. Next come to synthetic rubber. There are different types of synthetic rubber. First, chloroprene. So here, instead of this methyl group, if chlorine is there, this is known as your polychloroprene. So first, this is known as your chloroprene. This chloroprene, it undergo polymerization to form polychloroprene. Also known as neoprene. So this is one type of synthetic rubber. Okay, so this synthetic rubber is used, neoprene is used for manufacture of storing material, for storing petrol, oil, etc. These are also used for making belts. This is also used in making hoses, sew holes, like this. Okay, next come to another synthetic rubber, that is known as your Bunna S. So this chloroprene is also a homopolymer. Next come to Bunna S. This is a addition polymer. This is also a synthetic rubber, and this is a copolymer. That means two different monomer units are there. So one is butadiene, buta 1,3-diene, and another styrene. So these two undergo polymerization. N molecule of this and N molecule of this undergo polymerization to form Bunna S rubber, CH2CH. So here these undergo polymerization to form CH2CH, double bond CH, CH2, then CH, CH2, CH, so this is the repeating unit. This is known as your Bunna S, and this reaction takes place in presence of traces of sodium. That's why this is known as your Bunna S, also known as SBR, also known as SBR rubber, styrene butadiene rubber. This is generally used for the manufacture of tires for automobiles, for making it's generally used for different hoses and floor tiles, rubber slides, etc. So these are used for making tubes and tires for automobiles. Next come to another, that is known as your Bunna N. This is also a copolymer, and here the monomers are butadiene and acrylonitrile. That is acrylonitrile. So in this way, see, so this is your acrylonitrile. So this unit combines to form Bunna N. CH2. This undergo polymerization to form CH2, CH, CH, again CH2, CH, CN, CH2. This is bunna and this bunna N is used in making oil seeds, tank lines, etc. Okay, so these are some addition polymers. So some addition polymers are copolymers, some are homopolymers. So bunna S, bunna N, these are copolymers, but PVC, ethylene, and your chloroneoprene and polyisoprene, all these are homopolymers. Next come to another type of polymer that are known as condensation polymers. Next come to examples of some condensation polymers. First come to polyesters. So here ester is some, in the linkage there is some ester linkage, that's known as your polyester. One example is pterylene, also known as dacron. Pterylene, also known as dacron, and this is condensation polymer, and these are also known as your copolymers. This is also a copolymer. Her example is, so what are the monomer unit? Two monomer unit. One is ethylene glycol and another is known as ethylene glycol, and another is terephthalic acid. CH2, CH2, OH, and here OH plus COOH, benzene 1214, dicarboxylic acid. So n number of this and n number of ethylene glycol. This is ethylene glycol, or ethane 1,2-diol, and this is terephthalic acid, and these two undergo polymerization. So here H of alcohol and OH of this acid removed as water. So 2n minus 1 number of water molecule is removed and it undergo polymerization. So it forms, in this side also this hydrogen comes, links with another OH part of acid. So in this way O, CH2, CH2O, C double bond O, C double bond O. So this group is the repeating unit. This is known as your polyester pterylene. This is pterylene. And look here, the ester linkage, CO group is there. This is one alkyl part, we can say another alkyl part, and this is the ester linkage. That's why this is known as your polyester. One type of polyester is pterylene, dacron copolymer. So it is also, generally polyester is fibrous in nature. When this is blended with different fibers like cotton, wool, silk, it forms terrycot, terry wool, terry silk, like this. So for it is, these are used for synthetic fibers, for different synthetic fibers. So pterylene is used for different synthetic fibers. Next come to another polyester, that is known as your another type of polyester, that is known as your glycol. This is also a polyester and this is also a copolymer. And what are the monomer units? Here the monomer units same. Ethyl one unit is same. One is ethylene glycol and another is phthalic acid. That is 1,2-dicarboxylic acid. So this is phthalic acid and this is ethylene glycol. N molecules of this phthalic acid reacts with N molecules of ethylene glycol. It undergo polymerization to form glycol. O CH2 CH2 O C double bond O C double bond O. So in this way, okay, so this is the repeating unit here and here. It has also some what? Ester linkage. That's why this is known as your polyester glycol. And this is generally used, this glycol is generally used for making paints. These are generally used for making paints. Glycol is generally used for making paints. Okay. Next come to another type of condensation polymer that are known as your polyamides. Polyamides. These are called amides because they have amide linkage. They have amide linkage. Like our natural protein, they have amide linkage. That's why these are known as your polyamides. One of the polyamide is nylon 6. This is also known as another name of nylon 6 is known as Perlon. Okay, and what is the monomer unit? The monomer unit of nylon 6 is caprolactam. Caprolactam, and this caprolactam generally prepared from cyclohexane. So cyclohexane first undergo oxidation to form cyclohexanone. This is then treated with hydroxylamine to form an oxime, which undergo rearrangement to form caprolactam. So suppose we are taking the cyclohexanone and when it treated with hydroxylamine, this forms an cyclohexanone oxime. It undergo rearrangement Bachmann rearrangement. This is called Bachmann rearrangement. Bachmann rearrangement to form caprolactam. So it is a 7-membered ring, looks like 7-membered ring, and here 6 carbon, 1, 2, 3, 4, 5, 6. 6 number of carbon atom. This is known as your caprolactam. And this caprolactam when undergo hydrolysis. So you know this is caprolactam, and this caprolactam when undergo hydrolysis, okay, this is caprolactam. Actually cyclic amides are known as lactam, and there are 6 number of carbon atom. This is caproric acid, that's this is known as your caprolactam, and caprolactam undergo hydrolysis to form it forms 6-amino hexanoic acid, and this 6-amino hexanoic acid when undergo polymerization, it undergo polymerization. H of this amine group is there and carboxylic acid is there. H of this amine group and OH of this group linked to form, so this combine to form water. One molecule of this H and another molecule of COH. COH, suppose there is another this group, that is your 6-amino 6-amino hexanoic acid. If there is another 6-amino hexanoic acid, then OH of another acid and hydrogen of this amine group, it condenses to form this water molecule, and it forms NHCH25CO. So this group is the repeating unit. Okay, so this is caprolactam, and this is nylon 6. So why it is called nylon 6? Because it contains 6 number of carbon atom. That's why this is called nylon 6. And nylon 6 also known as porlone, and it is also this is a polyamide. Okay, condensation polymer, also a homopolymer. This is a homopolymer. Okay. Next come to another different types of amides, that is nylon 6,6. This is nylon 6. Next come to another, that is called nylon 6,6. Nylon 6,6. So this nylon 6,6, there are 2 monomer units. This is a copolymer, condensation polymer, as well as a copolymer. 2 different monomer unit. One is hexamethylene diamine, another adipic acid. So NH2 CH2 whole 6 NH2, this is hexamethylene diamine, hexamethylene diamine, and another adipic acid, this is adipic acid. N molecule of this and N molecule of this undergo condensation reaction to form, so OH of this amine and OH of this acid. So it forms also a condensation polymer. So it forms NH CH2 whole 6 NH, then CO CH2 whole 4 CO, and here again CO, here again NH, like this. So there is an amide linkage. Look here, there is an amide linkage. This is called nylon 6,6. Nylon 6,6. So this nylon, why this is called nylon 6,6? Because it contains 6 carbon atom from this amine group and the 6 carbon atom from this acid group. As it contains n number of this, so this is the repeating unit, nylon 6,6. In this way, this nylon 6,6 is formed. Next come to another polyamide, that is nylon 6,10. 6,10. This is also a copolymer. Difference is that this is one monomer unit is same hexamethylene diamine and another is sebacic acid, which contain 10 number of carbon atom. Sebacic acid, this is nylon 6,10. Okay, so why this is called 6,10? Because it contains 6 and 10 number of carbon atoms. So as it consists of 6 and 10 number of carbon atoms, that's why this is called nylon 6,10. And all these nylons have, whether nylon 6, nylon 6,6 or nylon 6,10, all have an amide linkage. And these nylons are generally fibrous nature, and these are generally, they have strong hydrogen, intermolecular hydrogen bonding. In this way, these are fibrous nature. These are used for manufacturing ropes, different for climbing ropes. These are used for bristles of brushes, like this. And some nylon are also used for, so as these are fibrous nature, these are also used for manufacturing different types of fabrics or clothes. Okay, so these are used for making ropes, clothes, bristles of brushes, like this. Next come to another type of condensation polymer, that is a three-dimensional network polymer, that is known as your Backylite. Backylite. Backylite is a condensation polymer, as well as this is a copolymer, and the monomer units are formaldehyde and phenol. So actually first formaldehyde reacts with this phenol to form orthohydroxy. So this is 2-hydroxybenzene methanol, okay, and another, so ortho product, and it forms a para product. It forms 2 isomers of this CH2OH group is joined. So first it forms like this, that is an orthohydroxy product and para hydroxy product. And when this orthohydroxybenzene methanol and para hydroxybenzene methanol, first it forms, And when this orthohydroxybenzene methanol undergo polymerization, it forms a linear polymer that is known as your Novlac. So first, n number of OH, CH2OH. Suppose there is another group is there, phenol is there. It also contains CH2OH. So there is one hydrogen. So OH of this and hydrogen of this. Removal of water takes place and it forms OH, CH2, OH, CH2. In this way, this group is continuing this side and this side also. Okay, so this is known as your Novlac. So this is known as your Novlac. Novlac is a linear polymer of formaldehyde and phenol. But if this is a linear polymer, but if these two isomers undergo polymerization, it forms a cross-linked polymer that is known as your Backylite. So this is OH, CH2OH plus n number of OH, CH2OH. So this undergo polymerization. To form. So if there are so many number of these isomers and so many number of these isomers, in this way it is linked to form So this is a cross-linked polymer. This is known as your Backylite. And Backylite is generally used for making different electrical equipments, that is electrical switches, plugs, etc. for making combs, etc. These are also used as adhesive. The soft Backylite, these are used as adhesive. These are used for making the formica tables. Okay, so these are the uses of Backylite. This is a thermosetting polymer, a copolymer. This is example of a copolymer, thermosetting polymer, a cross-linked polymer. And there are two types of Backylite: hard Backylite, soft Backylite. Soft Backylites are generally used for adhesive purpose, and strong Backylites are used for making different household goods as well as for making electrical switches, plugs, etc. Okay. So although there are so many number of synthetic polymers, but these synthetic polymers are generally non-biodegradable, and generally they cause hazard pollution to environment. So they have hazardous effect to environment. They causes environmental pollution. So in this way, it require for making more number of biopolymers or biodegradable polymers. So up to now, what we have studied, these are different synthetic polymers, and these synthetic polymers are generally non-biodegradable. These are generally not decomposed by acids, bases, or oxidizing agents or enzymes. In this way, this causes environmental pollution. To overcome this problem, generally it is required to prepare some biodegradable polymers. So generally biopolymers like proteins, cellulose, starch, glycogens, these are biodegradable. They undergo hydrolysis and decompose itself. But the synthetic polymers, these are non-biodegradable. In this way, it required for the preparation of some biodegradable synthetic polymers, or we can say artificial polymers. So what are biodegradable polymers? So these polymers which are degradable or decomposed by enzymes or by hydrolysis, these are known as your biodegradable polymers. And or we can say they are also known as artificial. These are also known as artificial biopolymers. Some examples are PHBB, polybeta hydroxy valerate beta hydroxy, polybeta hydroxy, B first is written, so butyrate and beta hydroxy valerate. So PHBV. So the monomers are beta hydroxy butanoic acid and beta hydroxy valeric acid. OH, CH, CH3, CH2, COOH. 3 hydroxy butanoic acid plus n large number of three hydroxy pentanoic acid. So this undergo polymerization. Here OH of acid and H of this hydroxy group, that is 2n-1 number of water molecules are removed to form OCH, CH3, CH2, COO, CH, CH2, CH3. Sorry, this one is acid. This one is acid, and this part again reacts. Pentanoic acid, this part again. So this forms your CO. Here this hydrogen again can be removed. So in this way, this is the repeating unit. Okay. So this is 3-hydroxybutanoic acid, 3-hydroxypentanoic acid, and this is your pH baby. Generally, this is used for orthopedic devices and capsules for drug delivery. Next, come to another example of biodegradable polymer. Another example of biodegradable polymer, that is nylon 2, nylon 6. So here the monomer units are glycine and 6-amino hexanoic acid. So glycine, NH2, CH2, COOH, n moles of this plus n moles of NH2, CH2 5, COOH. Here OH of acid and H of this amine group reacts to form water. In this way, when it undergoes polymerization, 2n-1 number of water molecule removed, and here also one hydrogen removed, and here also this OH group removed, which reacts with another molecule of this glycine. So in this way it formed NH, CH2, CO, NH, CH2 whole 5, CO. So this group is now repeated. This is known as your nylon 2, nylon 6, and this is fibrous nature. It is better over nylon 6. Nylon 6 is also a fibrous polymer. This is used for stitching, and nylon 2, nylon 6 is also a fibrous polymer, but this is biodegradable. So in this it is used for stitching wounds and cuts. Next, come to another example of biodegradable polymer, that is polyglycolic polylactic acid. Polyglycolic polylactic acid. Polyglycolic polylactic acid. Glycolic acid, OH, CH2, COOH. This is glycolic acid. Lactic acid, OH, CH, COOH, CH3. Here OH of n moles of this, n moles of this, OH of this, and H of this hydroxy part. It reacts to form water, and when it undergo polymerization, here also 2n-1 number of water molecule. This O can be removed by reacting with another part of lactic acid. This is glycolic acid. Glycolic acid, and this is lactic acid. So in this it forms OH is there, this hydrogen is removed. In this it forms O, CH2, CO, O, CH, CH3, CO. So this is the repeating unit, and this is also fibrous in nature, and this is also used for stitching wounds after operation. So these biodegradable polymers has several uses. These are used as stabilizer, thickeners, binders, dispersant, lubricants, adhesives, drug delivery agents. These are also used in cosmetics and textiles. So this is so these are some examples of biodegradable polymer, and here it completes the polymers chapter.